Hello again, grade 8s. In today's lesson, we're going to calculate the surface area of a right rectangular prism. Although before we do that, we'll define what the surface area of a three-dimensional object is and also talk about what the units of measurement are going to be. The learning outcome is to determine the surface area of right rectangular prisms to solve problems. To define surface area, let's start off by looking at a really simple shape. So that's a shape of a cube that we looked at last time. And the surface area of this cube is the sum of the areas of all the faces of an object. Now, if you look at that cube, this cube has 6 faces. It has a top and bottom face, it has a front and back face, and it has a left and right side face. If you take the area of all those faces and you add them all together, that's what we call the surface area of the object. In essence, what a surface area is, it's the area that is in contact with like all the air that would be like surrounding the object that you see. One way to look at the surface area, though, is we could take that three-dimensional object and break it into its net. So its net would be composed of 6 different squares. And the surface area is going to be the area of all these individual squares put together. So the area of the green face we'll call A1, A1 for area 1. The area of, now you can't quite see it, but there is a red face here. We'll call it A2. The blue face we'll call A3. The gray face, which again you can't quite see, is A4. This orange colored face is A5. And this purple colored face is A6. If you want the surface area of the cube, the surface area again is the sum. So when you calculate a sum, you add a bunch of things together. So it's the sum of all of these different areas put together. So that would be SA, which is an abbreviation for surface area, would be A1, the area face 1, plus A2, the area face 2, plus A3, the area face 3, plus A4, the area face 4, plus A5, the area face 5, plus A6, which is the area of face number 6. The units of measurement, whenever you talk about area or surface area, is going to be in square units. If you want to think about what the surface area actually is, if you looked at all the different faces, the number of square units that would be required to cover all those different faces, if you added all these square units together, that would end up giving you what the surface area of your object is. Okay, so we're going to be dealing with units that are squared. Steps for calculating surface area. And this is actually going to be the steps we're going to use to calculate the surface area for a right rectangular prism, a right triangular prism, and a right cylinder, which we'll be examining over the next 3 lessons. Step 1, you want to draw each distinct face and label the dimensions. So when I say distinct face, it means you only draw a face if it has a distinct length and a width to it. If 2 faces have the exact same length and width, then there's no need to draw 2 of them. Just draw 1 face, and then we'll multiply by 2 to identify the total area. 2, identify the number of times that each distinct face repeats. So that's kind of what I was saying. Like if you have 2 faces that have identical dimensions, we're just going to draw that face a single time, and then we're going to identify how many times that face repeats and multiply by that number. Then we calculate the area of each distinct face. And after we have the area of each distinct face, we add all the areas together to get the total surface area for your object. The next 3 lessons we're going to examine the surface area of a right rectangular prism. And the following lesson will be a right triangular prism. And then finally, we'll get into a right cylinder. So let's start with a right rectangular prism. That has the shape of the box that you can see on the slide here. A right rectangular prism consists of 6 rectangular faces. So the 6 faces would be you have a top, a bottom, a front, a back, and you have a left side and a right side. The sides that are opposite, the faces that are opposite, they are all congruent rectangles. Now, in terms of what that word congruent means, we haven't really talked about this since the first unit of study, but if you have shapes that are congruent, shapes that are congruent have the same shape and size. And all of the faces intersect at a 90-degree angle. So let me show you a couple of faces and how they would actually intersect. So let's take the front face. So we'll kind of like shade this one in. And let's take the right side face, which would be this one right here. Okay, if you look at the angle between these two faces, so that would be between this edge at the top and this edge right here. The angle between the two of those is going to be a right angle. This weird symbol, that's supposed to be a square, but it's like it's a square in 3 dimensions. So again, anytime you show like something that's a right angle, you do this. But in 3 dimensions, what I had is I was trying to draw a square kind of like that. Okay, that's supposed to be a square right here. Just to indicate that those two faces are perpendicular to each other. Okay, so let's go straight into doing some example problems. Now, there's actually quite a few steps involved in determining the surface area of an object. There's a lot of different things you have to do and a bunch of numbers you have to multiply and add together. All right, so it says calculate the surface area of the following right rectangular prism. In your solution, you must draw each distinct face and label the dimensions, and then calculate the area of each face. So the problem is just helping me by giving me a couple of guiding steps of how to do this. Okay, let's start off by looking at the front and the back face. So the front face is this one, okay? Now let's get rid of that vertical line. Okay, this is your front face. Now, I'm going to sketch a picture of what the front face looks like. If you have a ruler, I would recommend using a ruler to do this. But once again, I can't really use a ruler with a drawing tablet. So I'm going to do my best just to sketch this front face here. So the face I'm going to try to sketch is this one. And the back face is the exact same shape as well. So we'll say the front and the back. Front / back. Okay, so that's going to be a vertical rectangle. Again, if you got a ruler, I'd recommend doing it, or doing it with a ruler. Just makes it a bit neater. Okay, so there's my rectangle. Now, I also need to label the dimensions. Now, the way to label the dimensions is, let's say we want to label this bottom dimension here, this bottom length. So what I do is I draw a vertical line that kind of like starts at the one edge, and I draw another vertical line that goes to the other one. I draw a horizontal line that connects this, and I draw 2 little slashes that go through these endpoints. Okay. Now I'm going to label this length, so that's 8 centimeters. And then for this height length measurement, I'm going to start off by drawing a horizontal line at one edge, horizontal at the other. Then we do a vertical line that connects them. And then we do a little slash through one and a slash through another one. And then that's going to be 16 centimeters. Okay, now I'm also going to identify how many times this shape repeats. Well, this shape is the front and it's the back, so it's going to repeat twice. So I'm just going to write down ×2 just as a reminder that I'm going to have to take this shape and multiply by 2 to get the area of both the front and the back. Now let's calculate what the area of the front and the back is. So I'm going to write down AFB. AFB means the area of the front or the back. Now, this is the area of a rectangle. The area of a rectangle is just the length of the rectangle times the width of the rectangle. So we just multiply these two dimensions together. So this would be 8 centimeters multiplied by 16 centimeters. And then I would have the area of the front and the back, or front or the back. It's just the area of one of those. So 8 times 16 is 128. And because you're repeating the units, it's centimeters times centimeters. That's units of centimeters squared. And we already talked about how the units need to be square units. All right, that's the front and back face. Now let's go to a different face. So I'm going to erase all that. Let's do the left and the right side. Okay, so this would be the right side. Okay, so I want that face, and I want this one. I want the left, and I want the right. So let's say left / right. Okay, we're going to sketch a picture of what this looks like. Now, this will be a rectangle at the same height, except it's just going to be thinner. So we're going to have rectangle here. And let's label these dimensions. So this time, if you look at the picture, the length would be 3 centimeters. And the height of this would be 16 centimeters, the same height. And I try to draw the two pictures side by side just to illustrate that the heights are the same. Okay, how many times does this face repeat? It also repeats twice. So I'm going to write down multiplication by 2 because we're going to have to multiply the area of this face by 2 when we find the total surface area at the end. So we'll write down A, and I'll say ALR. So ALR means the area of the left or the right face. Once again, it's a rectangle, so the area of a rectangle is just length times width. So you'd go 3 centimeters multiplied by 16 centimeters. And then area of the left or the right face, 3 times 16 would be 48 square centimeters. Okay, we have one more distinct face to look at, or two faces. Two faces that just have the exact same area, and that's going to be the top and the bottom. Let's do red here. Okay, so here's my top face. Here's my bottom face. Okay, this one's the top. So we'll write down top / bottom. Okay, if you view this from a top view perspective, then it's probably going to look something like maybe like this. It's going to be the smallest of the rectangles that we have. Let's label the dimensions. So from the top, the length would be 8 centimeters. And then this side would have a length of the 3 centimeters that I have down here, or have a width of the 3 centimeters you have down there. So 3 centimeters. And this face repeats twice, so let's write down ×2. Then I'm going to write down ATB. So ATB means the area of the top or the bottom, and that would be equal to the area of the rectangle, which is 8 times 3, so 8 centimeters, length times width, times 3 centimeters. ATB is then going to be 8 times 3 is 24 square centimeters. All right, so I've drawn each distinct face. I've identified how many times they repeat. Each of these distinct face repeats twice, and I've calculated the area of every single face. Now, all I have to do now is just calculate the total surface area. So the total surface area would be equal to, it would be 2 times the area of the front or back. So I'm going to write down 2 AFB, because we have to multiply by 2 because we have a front and a back. We have 2 sides. We take the area of the front or the back and multiply by 2. So write down 2 AFB. Plus, we also have the left and right side. There's 2 of those faces. So we go 2 ALR plus, and we have the top and bottom distinct face. We have 2 of those. So you'd write down 2 ATB. So what you can see here is we have 6 faces. So we have 2 plus 2 plus 2. We have front and back, left and right, top and bottom. Now we can plug numbers into the equation and calculate this. So my surface area would be equal to 2 times the area of the front and the back, which is 128 square centimeters, plus 2 times the area of the left or right face, 48 square centimeters, plus 2 times 24 square centimeters. And if we keep breaking this down, we then have your surface area is 2 times 128 would be 256 centimeters squared, plus 2 times 48 would be 96 centimeters squared, plus 2 times 24 would be 48 centimeters squared. And then I'd have my surface area would then be equal to, if we add these 3 together, 256, 96, and 48, gives you 400. So your total surface area of this right rectangular prism is 400 centimeters squared. And that's the solution to example number 1. Okay, example number 2, a little more complicated. So it says a person wants to paint the walls and ceiling of a rectangular room. It says with dimensions shown in the diagram below. The combined area of the door and the windows is 5 meters squared. I want to calculate the surface area of the walls and the ceiling. Okay, so just note right here that we're only calculating the surface area of your 4 walls. So you'd have like, here's wall 1, here's wall 2, wall 3, wall 4, and we're calculating the ceiling. Okay, so the ceiling would be on the top here, so that would be number 5. If I like just kind of sketch the ceiling in. We're not going to calculate the surface area of the floor because we're not painting the floor. Okay, the person only wants to paint the walls and the ceiling. Therefore, we only have 5 faces we need to worry about here. Okay, so that's going to be the front, the back, the left, and the right, and the top of that rectangular room that we see. But we are not painting the floor, so we're not going to incorporate the surface area of the floor. Okay, so let's start off by doing that. Let's calculate the surface area of this. Now, it does tell me the combined area of the door and the windows is 5 meters squared. So we're going to have to remove that area after we figure out the total area of the front, the back, the left, and the right, and the top. Okay, we'll deal with that in a moment. In fact, I'll even write that down here. I'll say area of, I think it was the windows and the door. Surface area of, yeah, doors and windows. Okay, and that is equal to, the problem tells me it's 5 meters squared. All right, so we got to just draw our distinct faces. So I'm going to start off by doing the front and the back. So the front face would be this one. Now, for the time being, don't worry about the door, okay? We'll subtract off that area at the very end. We're just going to start off by calculating the area of the front and back of the room. Okay, so let's draw the front and the back. Let's do it over here, actually. I feel like I'm going to run out of space if I start on the right side. Okay, so we'll say the front and the back. So let's draw that. Label the dimensions. Okay, so this length, and again, use a ruler if you got one, 4.8 meters. And this height is 2.6 meters. Okay, so the area of the front and back, so I'll say AFB, is equal to area of a rectangle. So let's take the length and multiply by the height here. So 4.8 times 2.6. And the area of the front and the back, if we just plug this in, this is going to give you a decimal number. So 4.8 times 2.6 gives you 12.48. And the units are square meters. Okay, let's go to the left and right side now. And again, left and right side. Okay, so that's going to be this face. That's the left side. And this one right here. And for the time being, don't worry about the windows. Okay, we'll subtract that off at the end of the problem. Okay, so this is actually going to be quite a bit of a longer rectangle. So this is going to be the left and the right face. Okay, it's going to have the same height as the rectangle on this left-hand side, but it's just going to be longer. Okay, label the dimensions. So this rectangle is 6.8 meters across. And the height of that rectangle is 2.6 meters, same height as the other one. So we'll write down ALR, area of the left or the right face, is going to be, oh, by the way, we should identify how many times this repeats. So the front and the back repeats twice. The left and the right side, it also repeats twice. You have two of those faces. All right, so area of a rectangle, you'd have 6.8 meters multiplied by 2.6 meters. And the area of the left or the right face, 6.8 times 2.6 gives you 17.68 square meters. Now, we only have one other face to look at. So let's get rid of this, get rid of that. Okay, so we're also painting the ceiling. So the ceiling would be this top face. Now, again, we're not going to write down the bottom because we are not painting the floor. So we're not interested in the surface area of the floor. Okay, so this is going to be, I guess it depends on whatever perspective you want to draw this thing. So this is probably going to be the biggest rectangle. So this one's going to have, it's going to be quite a little bit further down here and quite a bit long. There's different ways you could orient these, by the way, in terms of like how you want to sketch the faces, but you do need to do this. You do need to sketch the faces and label the dimensions. Okay, so this big length would be the 6.8 meters. And then this length of the roof would be 4.8. Okay, so then the area of the top, so let's write down AT. That's going to be just the area of this rectangle. Now, this only occurs once, okay, because we're not incorporating the bottom. So we're just finding the area of the top. So that's going to be 6.8 meters multiplied by 4.8 meters. And that's going to give me the area of the top would be equal to, so 6.8 times 4.8 would be 32.64 square meters. Okay, I'm just going to abbreviate the area of the door and the windows as ADW. So we'll say ADW is 5 meters squared. Now let's write down a formula for the surface area. So this is part A. surface area that makes sense. Okay, so the total surface area that you're going to paint is going to be 2 times the area of the front or the back, plus 2 times the area of the left or right face, so 2 ALR, plus, now just 1 times the area of the top. So we'll just write down, we don't need to write down 1 times, we can just write down AT. Now, after you found the area of the left and right face, the front and back face, and the top, now you have to remove the door and the windows. Okay, so we're actually going to subtract off this number here. So we're going to remove ADW, okay, because we're not painting the windows and we're not painting the door. So we subtract that. Okay, so this would be equal to, the surface area is 2 multiplied by 12.48 meters squared, plus 2 times area LR, 17.68 square meters, and then plus area of the top, which is, oh, we forgot to calculate it. Oh, no, it's here. Yeah, 32.64. And then subtract the area of the windows and the doors, which is 5 square meters. Okay, so let's break this down step by step. So we're going to double 12.48. So 2 times 12.48 would be 24.96. The order of operations tells you have to do the multiplication first. Okay, then 2 times 17.68 would be 35.56 or 0.36 square meters, plus 32.64 meters squared, and then subtract 5 square meters. Okay, we've almost got our surface area now. Now we just need to either add these numbers, just add and subtract that 5 off the end. So 24.96 plus 35.36 plus 32.64 minus 5 gives me a total surface area that you're going to paint of 87.96 square meters. Okay, so we'll box that. Now, we had one other thing we needed to do. It wants to know the total cost to do this. So it says, suppose 1 liter of paint covers an area of 9.5 meters squared, and the cost per 1 liter of paint is $8. Determine the total cost to paint the walls and the ceiling. Well, first of all, I need to know how many liters of paint I need to use. So we know the total surface area is 87.96 meters squared. And it tells me that 1 liter of paint covers an area of 9.5 meters squared. So what I'm going to do is I'm going to take my surface area, which is 87.96 meters squared, and I'm going to divide that by this number here, okay? Because 1 liter of paint covers 9.5 meters squared. So divide it by 9.5 meters squared per liter. Okay, 1 liter is painting 9.5 meters squared, and if you divide those two numbers together, you get 87.96 divided by 9.5 is, now it's a big repeating decimal number. I'm just going to write it down to the nearest hundredth. So this would be 9.26 liters. Okay, so that's how many liters of paint I need. Now, it also tells me that 1 liter of paint is $8. So all I need to do now is take the number of liters of paint that is calculated and just multiply it by 8. So your total cost would be equal to, so take the number of liters of paint that I need and multiply by the cost per liter. And the cost per liter is $8 per liter. Multiply those two together, and when you write down a cost value, you should always be rounding to the nearest hundredth of a decimal, because the nearest hundredth of a decimal is the nearest cent. And if you do this correctly, you should get 74.07. So $74.07. That's a total cost to paint this thing. Okay, that's it for this lesson, and you can practice this by completing the assignment called Surface Area of Right Rectangular Prisms in the Surface Area and Volume Workbooklet. And then I'll talk to you in the next lesson where we look at finding the surface area of a right triangular prism. And I'll talk to you